So I made a short video here that explains how to do this problem that many of us were having problems with during SI today. So the problem reads, how many tangent lines to the curve y is equal to x over x plus 3 pass through the point 1, 2, and at which point do these tangent lines touch the curve? So the first thing we have to check is we have to check if the point 1, 2 is on the curve x over x plus 3. So to do that, we are going to plug in 1, 2 into the function. Y evaluated at 1 is equal to 1 over 1 plus 3. And I plugged this into this function. So y of 1 is equal to 1 over 4. That's when I plug it into the function. Does it match the output that is given, which is 2? It doesn't match 2. So therefore, the point 1, 2 is not on the curve. So step 1 is done. So basically what this question is asking us to do is if I sketch this graph, here are my x and y coordinates, and I sketch a graph, specifically this one in the problem, but I'm just going to sketch this one, and I have a point. This is my graph, y equals f of x. This is the point, x, f of x, which is any point on the graph, f of x. And here's a point, call it AB, and in our case this point is 1, 2, but we can call it AB, and we want to see if I draw a tangent line to this curve. I know this doesn't look like a tangent line, but if I draw the tangent line to this curve, how many of these f of x's cross AB, which is 1, 2. It looks better in this picture. So again, if I'm looking at f of x on my function, this is any point on my graph y equals f of x. Any point is f of x. AB is the point that we want the tangent line to cross, and so I have to find um, the points that cross at that point. How are we going to do that? Well, basically, I want this line to resemble, this is the slope. I want the slope of the line to pass through 1, 2. What's the equation from algebra that gives us that? It's the slope of the tangent line, which is equal to y2 minus y1 over x2 minus x1. In our case, we want to find every point on the graph f of x that passes through the point AB. So in our case, every point on the graph is f of x, y2 is f of x minus b over x minus a. So we can find the slope of the tangent line at f of x by taking the derivative. Of f of x. What I mean by that is, yes, I drew the tangent line here, but I don't know what the slope of the tangent line is. I don't know what the rate of change of that line is. And so I know that it's in terms of f of x and b and a, but this is going to be equal to, the slope, m tan, can be equal to f prime of x. And recall from chapter 2, this looks like the definition of the derivative. The definition of the derivative said that the limit as x approaches a of f of x minus f of a over x minus a is the derivative. So recall that this looks identical to this, where f of a in this case is already solved for us. It's b. So a, b, or you can replace b with f of a. So basically what I'm doing is I have m tan, which is the derivative, set equal to the derivative. And I know how to take the derivative, and I know how to do the change in slope. This is going to help me in solving this equation because I can set two equations equal to each other and then make it equal to 0 and solve for x. Without this second equation, then I can't do that. So this is a derivative, this is a derivative. They're going to look different, but they are equal to each other. This is just done using the shortcut rule for derivatives, which is going to be the quotient rule. This is going to be done the old-fashioned way, y2 minus y1. They're still equal to, in a sense, that they're both the slope or both the derivative, but the only reason I'm putting them equal to each other is so I can solve for 0. And so what does that look like now? Let me flip the page. So in my case, I have f of x is equal to x over x plus 3, and I have the point 1, 2. And so filling in my derivative, first of all, how do I get derivative from quotient rule? It's down. Derivative of the top is 1, minus up. Derivative of the bottom is also 1, all over x plus 3 all squared. This simplifies to x plus 3 minus x over x plus 3 squared. These x's cancel. This is equal to 3 over x plus 3 all squared, and that is f prime of x. So f prime of x is equal to 3 over x plus 3 squared. Now, to find my other definition, I have mtan is equal to f of x minus b over x minus a. This is equal to f of x. I have the function x over x plus 3 minus b I have is 2 over x minus a is 1. And so now I'm going to set this function equal to this function because they are equal. The slope, I said f prime is equal to the slope. When we do f prime, it's equal to the derivative, it's equal to rate of change like we've said before. So those two functions can be set equal to each other, and then we can solve for 0. I'm going to simplify this a little bit so it'll be easier to solve. How do I add or subtract fractions? From back in algebra and in chapter 2, we said that we need common denominators, so multiply this side by x plus 3 over x plus 3. This will be equal to x over x plus 3 minus 2 times x plus 3 over x plus 3 all over x minus 1. Combine the denominators. I have x minus, let's expand this out, give the 2 to both terms. This is minus 2x, keep the parentheses, plus 6 all over x plus 3 all over x minus 1. This is going to be equal to, distribute the negative, x minus 2x minus 6 over, we can pull this up, x plus 3 times x minus 1. Simplify the numerator. X minus 2x is just negative x minus 6 all over x plus 3 times x minus 1. And I can pull out a negative on the top. This is equal to negative times x plus 6 all over x plus 3 times x minus 1. Now what we're going to do is we're going to set these two equal to each other. This is mtan, and this is the derivative. So we're going to set them equal to each other because they are equal to each other. So we're going to say 3 over x plus 3 squared is equal to negative x plus 6 all over x plus 3 times x minus 1. How do I solve for x in this case? Well, I'm going to cross multiply. That's from pre-calc or from algebra. We're going to cross multiply. So I'll flip the page here. Three over x plus 3 squared is equal to negative x plus 6 over x plus 3 times x minus 1. So the next step here, we're going to do the cross multiplication. what's going to be left is 3 times x plus 3 times x minus 1, which is going to be equal to negative x plus 6 times x plus 3 squared. How do I solve for x in any equation? I'm going to set it equal to 0. So I'm going to move this term to this side. Now, this is a term that's stuck by multiplication. So I can add the entire term. I can't split it up, but I can add the entire term to the other side. This is a negative. To move it to the other side, it becomes 3 times x plus 3 times x minus 1. Stays the same. Now add this. Because it's a negative, it becomes plus. So I'm adding this term plus x plus 6, x plus 3 squared. Now it's equal to 0. Now this is the crucial step here. If you don't see this, then you're going to be doing a lot of messy work. So this is the step in the problem where we were messing up during SI. Here we can expand everything out, or we have this term stuck by multiplication, this term stuck by multiplication, and the common factor in both of them is x plus 3. So I'm going to pull out an x plus 3. What's going to be left here is 3 times x minus 1 from this term, and x plus 6 times just 1x plus 3 in this term. And this is still going to be equal to 0. Now we got rid of the cubic, because now we can only, when we expand all this out, we're going to get a squared function, not a cube. So crucial step here, unless you want to be factoring a cubic, you should have recognized that x plus 3 is a common factor in both terms, so we can pull it out in front. And you can always check your work, because if you factor this back in to both terms, you get your original line. So now I'm going to expand the big parenthesis out. X plus 3 stays the same. This is going to become, give the 3 to both terms, 3x minus 3, plus we're going to expand this out. So x to both terms, and then the 6 to both terms. So it becomes x squared plus 3x plus 6x plus 18 equals 0. X plus 3 times, now we're going to combine. X squared comes out in front. 3x plus 3x is 6x, plus another 6x is 12x. Negative 3 plus 18 is positive 15. This is going to be equal to 0. We can set both terms equal to 0 now. X plus 3 is equal to 0. X squared plus 12x plus 15 equals 0. X plus 3 equals 0. This one's easy. X equals negative 3. Now, over here we come, and we're going to try to factor this out. And I've already done the problem, and it does not factor out. So what are we going to use? We're going to use the quadratic formula. Opposite of b plus or minus the square root of 4 of b squared minus 4ac all over 2a. Once you plug in for the quadratic, a is equal to 1, b is equal to 12, c is equal to 15, you should get x is equal to negative 6 plus or minus the square root of 21. So I won't show you that. That's from algebra. You can do that in your calculator, and you can get x is equal to negative 6 plus or minus the square root of 21. Now I have 3 points in which the tangent line crosses the point at 1, 2. X equals negative 3, x equals negative 6 plus the square root of 21, and x equals negative 6 minus the square root of 21. And so, to answer the first part of the question, how many tangent lines pass through the point 1, 2? It's 3. If you didn't recognize that the function is y equals x over x plus 3. What's the domain of this function? This is all real numbers except negative 3. So this point will not be part of the problem. The 2 points are x equals negative 6 plus 20 plus the square root of 21, and x equals negative 6 minus the square root of 21. So how many tangent lines to the curve pass through the point 1, 2? The answer is 2. 2 tangent lines cross the point 1, 2. In the next question, They ask, at which points do these tangent lines touch the curve? At which points? Well, x equals this, x equals that. We have to get the y values. X equals -6 plus the square root of 21. If I plug it back into this function, my y function, what do I get? I get y is equal to -6 plus the square root of 21 over x is -6 plus the square root of 21 plus 3. This is equal to -6 plus the square root of 21 over -3 plus the square root of 21. So at the point x equals -6 plus the square root of 21, y equals -6 plus the square root of 21 over -3 plus the square root of 21. The negatives do not cancel because this is stuck by addition and subtraction. And for the other x point, x equals -6 minus the square root of 21, you can do the same thing. You get y is equal to -6 plus the square root of 21 over -3 minus the square root of 21. This is going to be minus on the top, sorry. So your 2 points are -6 plus the square root of 21, -6 plus the square root of 21, -3 plus the square root of 21, combination x and y, and x equals -6 minus the square root of 21, y equals -6 minus the square root of 21 over -3 minus the square root of 21. And that's how you do that problem. It is fair game for your exam because this is part of section 3.2. And so it could be on your exam. If you think about it, it is a fair question for your exam. So in the past, I haven't seen them ask anything like that. That does not mean by any means that it can't be on your exam this semester. So please know how to do that problem. Now we're going to go through just a quick review of the chain rule from lecture today. So in our SI, we talked about the chain rule, and I'm just going to do some more problems here real quick. So this is section 3.4, chain rule. And we said that the chain rule is a composition of two functions. H of x, let's say, is the composition f of g of x. When I take the derivative of h prime, or of h of x, when I take the derivative of h of x, I get h prime of x. This becomes the derivative of the outer function, which is f prime. We keep the inside function the same, and we multiply by the derivative of the inside function, which is g. So we get g prime of x. This is the chain rule. It is the most common used in all derivatives. All derivatives take the shape of this chain rule. For example, if I have y equals x squared, y prime is equal to, yes, we know it's 2x, but why? It's because the outer function is a squared function. I bring down the 2, keep the inner function the same, x, decrease the power by 1, and take the derivative of the inside function, which is x, which is just 1. So we get the derivative is equal to 2x. Now for other problems, example 1. Let's try f of x is equal to sine of 3x squared plus x. The derivative is a chain rule. The inside function is a 3x squared plus x. The outer function is sine. So we take the derivative of the outside function. What's the derivative of sine? Cosine. We keep the inside function the same, and we multiply by the derivative of the inside function, which is 6x plus 1. Another way of writing this, the more correct way, is we move the 6x plus 1 out in front, and then we say cosine of 3x squared plus x. This is to not confuse the 6x plus 1 as being with the cosine, which it's not. You can also do chain rule with the exponential function. So if I have e to the function w to the fourth minus 3w squared plus 9, this is equal to y. If I take the derivative, y prime is equal to, keep the exponential function the same, or the derivative of the exponential function is e to the whatever function it is stays the same, multiplied by the derivative of the upper function, which is 4w to the third minus 6w plus 0. So that would be your answer. You can do it with the secant function as well. Let's take an example, example 3. Y is equal to secant of 1 minus 5x. Then the derivative, dy dx, let's say, is equal to, take the derivative of secant, which is secant x tangent x. Keep the inside functions the same. Multiply by the derivative of the inside function, which is 1 minus 5x. The derivative is negative 5. And we can move the negative 5 out in front. Dy dx is equal to negative 5 secant of 1 minus 5x tangent 1 minus 5x. Other more complex examples require you to realize that something is a function. So if I give you like y equals, let's say, 2x times h of x times e to the 2x, and I say where h is a differentiable function, take a second and try to answer that question. So here, h is a differentiable function, means I can differentiate it. It's not a variable like x. So when I take the derivative, dy dx, is the derivative in terms of x. H of x is not x. So when I take this, this is going to be a product rule. We're going to take the derivative of the first term, which is the derivative of 2x is just 2. We're going to keep the other two functions the same. Plus, we're going to keep the first function the same. Now we're going to take the derivative of h of x. The derivative of h of x in terms of x is going to be a chain rule. You're going to take the derivative of the outside, keep the inside functions the same, multiply by the derivative of the inside. And then we're going to keep e to the 2x the same. This is the chain. So h of x has a function, let's say x in the middle of it. So it's h prime of x times x prime, which is the derivative of the inside function, plus keep the first two functions the same, multiply by the derivative of e to the 2x, which is another chain. Take the derivative of e, which is e to the 2x times the derivative of the inside is just 2. So your derivative here is dy dx equals 2h of x e to the 2x plus 2x h prime of x times x prime e to the 2x plus 2x h of x e to the 2x times 2. And we will be doing more examples like this in class as we learn the logarithmic rules, the inverse trig rules, and so on and so forth. We can try one more actually that just came up, example 5. Y is equal to, well, I'll say f of z is equal to sine of z e to the z. This is a chain. Once I take the derivative of the sine function is cosine. Keep the inside function the same. Multiply by the derivative of the inside, which is a product rule. So take the derivative of z is 1. keep the other function the same, plus keep z the same, take the derivative of e to the z, which is e to the z, and that's your answer. If you have any questions, feel free to email me. Like I said, from now till the next exam, most derivatives we do are going to be of the form of chain rule. Implicit differentiation uses chain rule, related rates use chain rule, and so we're going to be working with these for the rest of the chapter. So try to understand these basic problems because we will be adding on Wednesday and on Friday, and next week we'll be adding on more complex problems with the chain rule. If you have any questions, email me. This is Ahmad signing off.